Welcome back to graphics programming, surprisingly, in assembly language. I think we left off with a red square, so let's go ahead and get that running again. I'm using, of course, the bat file to run it, so if you want to see what those commands are, they are in here. So let's see if we can zoom in a little bit. So just a reminder, NASM and then QEMU. So those two commands. %sign means the name of the file. But we're going to be probably changing up sort of how that works soon because the bootloader only has, 512 bytes of space. So yeah. Anyways, so we're on to interrupt timers. And this is sort of an important thing because it actually gives you movement in the game. So we're going to be moving a square around the screen, hopefully, and maybe changing colors. So the first thing that we got to do is we probably need to grab we need to set up some constants for the interrupt timer because we need to know how often we want it to tick and what we want it to do. So it's called a programmable interrupt timer. So we're going to do command equals 0x43, and then we have a pit channel 0, and that one is equal to 0x40. Okay, and then pit frequency is now this is like the base frequency for it, so it's like a hard-coded value. So I have to look over here and see what that value is so I don't get it wrong. At least I believe it's hard-coded. Okay, I did make a mistake. That is normal for programming, making mistakes. Just so everybody knows, desired frequency. Okay. Hue 60, sure, that's fine. And then the divisor. And the divisor just tells you basically how to calculate that frequency. So I think it's like frequency, yeah, divided by desired frequency. Okay. All right, so those are the constants you need for setting this thing up. And then we got to move on basically to setting up the events. So we've got our drawing code here. I think we're going to keep that the same. We're going to need to be able to draw a single pixel as well. So I'm going to go ahead and put in some single pixel code. So draw, let's see, draw a pixel. Yeah, I think that we can remove draw a square for now since that's going to be changing. In fact, I kind of want to call it draw box because it's not technically a square, it's a rectangle, and box is a little bit, it's short still and whatever. All right, so in order to put a pixel, you basically just do this. And there's a little bit more to it because you got to calculate where this value starts, but you can do that with this thing. So yeah, I'm not going to test that yet, but you do need a return, so a return. Okay. We'll put the timer code at the bottom. So first we need a timer event. And this is going to be where our timer logic will go. So we're just going to have a return for now. And then we need a timer setup, probably. And this is what we're going to call to set up the timer parameters. So that will actually end up being called here, call timer setup. Because that's going to be the thing that starts everything. Now, this is a little bit more abstract. Well, it's a lot of data and it's a lot of just filling out values so that the chip knows what to do. So it's a little boring. But anyways, no, I do want CLI, STI, and then, all right. And we're going to need to essentially move bytes around and tell it what to do. And I already have this, and it's something where it's like, there's not a unique way of doing it. So I'm going to copy over the values so I don't have to type everything, because I've done this before. I've done all these things before, which is kind of why I'm making, I don't know, tutorials out of them, because it's good to, like, when you build something, to rebuild it so that you sort of like reinforce what you're doing, and also allows people to kind of see. Okay, so there's some comments here too. This is like a rate generator. You could spend a lot of time thinking about rate generation. It's not that important. Basically, yeah, you don't have to worry about all this stuff. But you can see the constants from before. So let's go over that. These are the constants, okay? And here's where they're used. So you tell it what command is for. So this out basically sends a command out to a functional piece of the chip, which happens to be the programmable interrupt timer. You move the divisor into the AX register because it's going to look there for the value, and then you output the low byte of the AX register. So AL, see these AL and AH? That's what makes up the AX register. I should probably at some point get a picture for you. Maybe I'll put it in post or something, or in the comments below. I don't know. It would probably be in the description. I think that's probably where it'll end up. But there's a whole structure to this with the A through D registers and a bunch of other stuff. So if you're interested in that, I'll put it in the description. Okay, and then you do out for the pit channel on AL, but you've moved AH into AL. So you start with moving the divisor into AX, and then you move 1 byte, the low byte, okay, into the out, okay, so you send that off, and then you move the high byte, which is the one next to it, into the low byte position, and then you also send that off from the low byte position as well. You probably don't have to do this move. I'm guessing you could probably do AH and it would work fine, and we can try that. But see, this is why I program things multiple times, because I start to think about ways to improve it. Okay. Now these things here, okay, are specific locations. You can see because they have a square bracket around them. We're dealing with a specific location, and we are moving values into there. So this timer interrupt label, which I haven't created yet, and probably should up here. Timer interrupt is the actual like event. I think it's an IRET. Yeah, it's IRET, I believe. Let me double check on that and make sure I'm not making some drastic mistake. Yeah, okay, and it needs a few other parameters. So first of all, we're going to call the timer event from here, because we want a timer event that is separate from all the little functional code that we need inside of the timer interrupt. Okay, move AL 0x20 out 0x20. Okay, so this is also telling you that the timer interrupt event has ended by sending an out. Anyways, I hope that kind of makes sense. Anyways, so this is the functional code of the interrupt. This is the programming code that we're going to add to the interrupt. Okay, so I believe this is all done, and let me make sure that I'm not making, okay, good. That all looks good. So in theory, right now, it should run, but nothing will happen. So I wanted to have something happen. So what we're gonna do is actually just call the draw pixel, and we're gonna do a really lazy thing. And that is we're gonna set the EDI start in here. And we're gonna move it to the start, but it's gonna be hard for you to see on YouTube, so I'm gonna add about, I don't know, 5,000 or something to it, so that it's sort of in the middle of the screen. And then we'll just go ahead and run this. I don't know if it'll work. Okay, it drew 1 pixel, but it didn't continue, and that's because we need to do EDI inc EDI. Okay. And then we'll do this, and we'll see if the timer's actually, yes, the timer's working. You can see it's working. All right. And you can see that it's slowly filling the screen red. Very slowly. At a rate of, I think we set it to 60, so 60 frames per second. 60 megahertz. Okay, now I got to test whether or not I was right about this AH thing. So we're just going to go ahead and comment that out. And instead of moving AL, we'll do AH here, and we'll see if we can actually reduce this by the number of lines of code. Aha. Invalid combination of opcodes. Okay, so in other words, AH is not accessible from out. That's very interesting. I wouldn't have expected that. I would have expected just be able to reference something. But the more you know. So that's why they do that. Okay, so we know more now. Okay, so now it's working. But you can adjust these things. I mean, we can up this to like 144. I think that's what a lot of monitors now go off of and see what happens. Yeah, it goes a lot faster now. Okay, but now what I want to talk about, because we have this done and that's really great and all, but what I want to talk about is colors. And I had them written down somewhere. Not in there. I think it would have been, here, I think. Yeah. So I have them all written down here. So you can see black, blue, green, cayenne, red, magenta, brown. Okay, you get the point. And I was thinking, okay, I really like using light green because I've been using that. So a long story short, I started out trying to build Pong in assembly language. I ended up writing a low-level language to do it, and then I built Pong in that low-level language. And now I'm revisiting the assembly because I want to make sure I get it right. Because I want the foundation of the low-level language to be good. And there's videos on the YouTube about that. If you look, the most recent ones are pretty much about that. But I kind of want something different for this particular series because I want it just to be focused on the assembly. So we can just copy these constants over. I'm going to remove this value. I was doing this because when you're generating code I was using C# as the translator, you don't really want someone to be able to put in a variable name like, jump, and then they've inserted a command instead of a variable. So you put value in front so that it makes sure it's never mistaken for a command. Anyways, but what you can do here is instead of moving the color in as a hex code, which is maybe a little bit, we already did change it to say color red. Okay, well, we can get rid of that. We don't need those anymore. You can do this thing where you do the constant colors dot, and then you have all this, see? And some people may recognize this from other, so we'll change it to light red just to see what the difference is. And this obviously isn't a real variable anymore, so let's do that. All right, so that's light red, which is kind of cool. All right, so now that we got colors, we got the timer, we need to move the box around. And the box, okay, here, has a draw start, an X and a Y, okay, that's defined. And we also have a width and a height. So we just need to like redefine this, but we also need to draw a box that covers the entire screen. So what we want to do is instead of moving the EDI here, because we don't need that anymore, because we're not going to use this little, I think I'm going to rename this to fill pixel, because it's not really drawing a pixel at a location, it's just filling the screen. And so we're going to go down here, and instead of draw pixel, we're going to say draw, it was a box, what was draw box? Okay. And we need to set these values. So we need to set the X and Y somewhere. So what we're going to go ahead and do is just say, we're going to have it move across the screen along the X. So we'll do the X here. we'll say move, it'd be EAX, I believe, and we're moving the SQX into EAX. Then we need to increment EAX, and then we need to move the value from EAX into SQX. So the source is EAX. Okay. And then we draw a box. So for this case, the x's actually, we'll start it at like, I don't know, 10 or something instead of there. It's going to call this, it's going to move that, and then theoretically we'll draw a box, and it'll drag it all the way across the screen. That doesn't mean that it'll look quite right. You will see why. So yeah, something's wrong. So what we need to understand is there's two draw box things that needs to happen here, and one is to clear the entire screen. So the thing is that if we want to clear the screen, there's a variety of ways to do this. The easiest way is just to draw a black box, and we'll probably do that for now because that's a good idea. But another way to do this is to set the color, okay, and we need a colors variable to determine what that color is. So here we are making a color variable, but this is slightly different, okay, because it's just a byte. So color draw is db, and then we'll just do 0 for now. That's black. Okay, and then up here we need to actually like utilize it. So we need to move the color draw into AL, and then is EAX used anywhere? Okay, well we'll just push EAX while we do this so that we don't interrupt whatever else we're doing, and then we will pop EAX afterwards. That way we stick it on the stack so that we save it, we use it, it gets changed, and then we change it back to whatever it was before by popping it. You get the point. All right, so what we need to do is, okay, we move it into AL, and then we move AL as a byte. Yeah, that's right. Okay. So I believe this should work. It'll just do black with this right now because we haven't assigned it, but we're gonna assign a color here. So move color draw, and then what should I move it from? We can just do, it's a byte, so we can just do AL again, and then move AL. What are we moving into AL? Colors dot green. Sure. Okay. And then in theory, that is not green. That's not green. Did we get this wrong? Is it blue? Is one green? Is the other one? Okay. Anyways, colors.blue. Let's see what blue is. We may have these codes wrong. I may have gotten them wrong. Well, it still thinks it's that. So there's something definitely not happening quite right. This is a single byte. Let's see here. Move a. Oh, you know what? Oh, I know what I did wrong. This is backwards. Backwards. And in fact, assembly does things backwards. If you're moving this value or this value into this value, that's backwards. It should be that other way around so that it's logical, but that's okay. So what I guess what was happening is, yeah, this is blue, okay. And so we'll set this to green again. Logically it's backwards, but in terms of code. Okay, yeah, green, okay. We've got green. Now, what we want to do is copy this entire code. And we want to have a different color for the background than we do for the foreground. So one of these will be black, probably the one that's done first. We will not increment this for the black one because we will be drawing underneath the previous one. And I don't want to do the whole screen because, well, one, it's unnecessary, and two, it would require me to reset all values, and I don't want to do that. So, and now if we do this, I think we'll have a little bit of progress. Yeah, okay, kind of. But you can see that it's like glitchy. And the reason why it's glitchy is we probably have 144 hertz for this little tiny machine is probably not, our simulated machine is probably not quite right. So there's probably a reason I did 60 before, and we're not double buffering, so. Yeah, that is, oh, hey, I don't know what's up with that, but now that I just made it full screen, it's fine. So as you can see, it, I don't know why there's a little tiny, I don't even know if you can see that little tiny pixel. As you can see, we can move a box across the screen, which is great. It's a little janky, but we can do it. And I think that's probably a good place to end this video. So I'll say a few things for the end of it, is that to explain. Basically, I'm doing programming in assembly, not because, you know, I mean, some of it's just novelty, is like, oh, how's it done? But because I'm trying to build up a good understanding of assembly so that I can make a programming language, a low-level programming language, designed for building operating systems, which is why we're doing things the way we're doing it, and why we're not utilizing anything like, you know, existing libraries, for instance. For instance, Windows has an existing library you can utilize for this sort of thing. So anyways, I'll see everybody later. Bye.